Hi guys, let me finish getting set up here. Okay, so at the time that you guys are watching this, I should, Lord willing, be boarding a plane. I'm heading to Illinois this weekend. I'm officiating my nephew's wedding, and we had problems getting flights, and it turned out we had to get one Thursday afternoon, which meant I couldn't stick around this afternoon. So I don't get to see your smiling faces. At the time I'm doing this, Mr. Passy had agreed to cover my class for me, so I will assume that he's still there with you guys. So let's start class with some typical stuff. For example, Jay, sit down and behave yourself. Mr. Clough, Mr. Cooper, put your phones away, right? I mean, that's pretty much how it starts all the time, isn't it? Sorry, fellas, I apologize for picking on you. But yes, behave yourselves for Mr. Passy, got it? So I have created this video just at a normal pace, and Mr. Passy can pause it as need be for you guys to catch up with getting all your notes filled in. And I will apologize ahead of time also because at the time of making this, I haven't gone through these slides in class yet. Therefore, I don't know about any mistakes in the notes, but you know it always happens, right? I never get this right. Somehow, some way, there'll be mistakes in here, so I'll just apologize ahead of time for that. All right, so here we go. We are getting into the integumentary system. Our skin. That should be maybe one of the easiest ones, right? Our cutaneous membrane, that's what we call the skin. It's a dry membrane, you may have noticed that. And it's our outermost protective boundary. The superficial epidermis is composed of keratinized stratified squamous epithelium. And you should all remember that because we just went through that section, right? Multiple layers of flattened cells. Then the underlying layer is dermis. And you should remember that that is made of dense connective tissue. Another one we just went through. So I'm not telling you anything you don't already know here, right? This is, I think, my favorite slide all year because they literally made us a slide to show us where our skin is. Like I don't imagine you could have found your skin without this slide pointing it out to you. So there you go. Now you know where your skin is. The cutaneous membrane. All right, the integumentary system is composed of our skin and the derivatives of our skin. Things like sweat glands, oil glands, hair, and our nails. The functions of our skin. It protects deeper tissues from mechanical damage, from chemical damage, bacterial damage, UV damage, from temperature extremes, from drying out, desiccation. And if you read over in the right column, it goes through explaining how that happens. So with mechanical damage, it's just a physical barrier that keeps a wall between outside and inside. The chemical damage in the keratinized cells here, the keratin gets used a lot for these functions in our skin. And it also controls or contains pain receptors, which alerts us to possible damage. We also have in our unbroken surface an acid mantle, skin secretions that are acidic and they can inhibit bacterial growth. We have melanin in our skin produced by melanocytes that offers us UV protection. We also have heat and cold and pain receptors. We also have waterproofing built in with our keratin and glycolipids. We also have the aiding in body heat loss and retention. So we get that is accomplished as far as the heat loss is concerned by activating sweat glands and by allowing blood to flush into the capillaries so that heat can radiate from the skin surface. And for heat retention, we do that by not allowing blood to flush into the skin capillary beds. It also aids in the excretion of urea and uric acid that is contained in our sweat. And it can synthesize vitamin D, which is a modified cholesterol molecule, and it gets converted to vitamin D by sunlight. So our skin does an awful lot for us. 2 layers. Epidermis, the outer layer, that's our stratified squamous epithelium, and it's heavily keratinized. And then the other layer is our dermis, the dense connective tissue, and both of these are composed of multiple layers. And now we will go through what those different layers are for the epidermis and the dermis. Here's an illustration of that. You see the dermis, the epidermis being on top. I got this cool pen. Let's see if this works. No, hang on with me. It's not working. There it is. See? Told you I got this cool pen. Anyway, everything basically from there on up is the dermis. We have 5 layers. And then below, everything from there on up is the epidermis. We got 5 layers. And then below is the dermis. And there's 2 layers in there that we'll go through. If we go below the dermis, they call that hypodermis or subcutaneous tissue. That's not considered part of the skin, but it anchors everything to the underlying organs, and that is mostly composed of adipose tissue. Another one we just went through in the tissue section. So the layers of the epidermis. The deepest, we're going to go from the deepest, from deep to superficial. The deepest layer of the epidermis is the stratum basal, sometimes also called germinativum. It lies right on top of the dermis, and in here we still have all live cells that continue to undergo mitosis. Their daughter cells that are created get pushed upward, so they get pushed superficially to become those superficial layers. And most of what that is cells called keratinocytes. Keratinocytes. Then next we have the stratum spinosum, also called the prickly layer, because that's the way it looks on microscope slides. They are spiny shaped cells, and they function to add strength and flexibility to the skin. Then we have the stratum granulosum. Here the cells become highly granulated, meaning they get filled with keratin, and they connect to one another through desmosomes. Those are anchoring connections between the cells. And through this, with the keratin and the desmosomes hooking them all together, they form a barrier to prevent water loss. Then we have the stratum lucidum. This layer is formed from the dead cells of the deeper strata. And this layer only occurs in the thick, hairless skin of the palms of the hands and the soles of the feet. And if you ever notice, those are the areas where you could get calluses. And those calluses are a buildup of this stratum lucidum. And that's why sometimes they get too big. If you're like me, you pick those calluses off. Anyway, it doesn't hurt or anything because it is a layer of it's a dead layer. You're not into anything that is vascularized or anything like that. Then we have the stratum corneum, the most superficial layer. Here we have shingle-like dead cells that are filled with keratin. And that's the layer that we were talking about this one day, and I don't know which, I think all the classes. Anyway, we're constantly sloughing off these excess dead cells. We leave them behind everywhere we go, and that comes from the stratum corneum. So, from deepest to most superficial, stratum basal, stratum spinosum, stratum granulosum, stratum lucidum on our palms and on the soles of our feet, and stratum corneum. And I'll just tell you, if we go the other direction from superficial to deep, there's a, what do you call it, an acrostic or what's the word? What do you call it when you come up with something to help remember it? Somebody tell me. Anybody? Mnemonic, isn't that it? Anyway, whatever the word is. If we go from superficial to deep, and we just assume the word stratum and just focus on the other word, some people say it this way: come, let's get sunburned. I didn't make that up, but I kind of wish I would have. And I guess it applies because we're talking about skin. But come, let's get sunburned. I would not recommend that, but it is a good way to remember the first letter of each of those layers going from superficial to deep. So use that as you wish. I'll give you that for free today. I won't charge you for that. Then we need to talk about melanin, the pigment that's produced by melanocytes. Melanocytes are mostly in the stratum basal. Color is yellow to brown to black, just depending on how much melanin you have produced. And the amount of that melanin produced depends on your genetics and your exposure to sunlight. That will generate an increase in the production of melanin. You know, a public service announcement here. It's really sad how our world gets all hung up on skin color. And all it is varying amounts of melanin. It's kind of a shame that people get hung up on that so much. So down to the dermis. 2 layers. First is the papillary layer, the upper dermal region. It has projections called dermal papillae, and some contain capillary loops, so we're getting into vascular regions. And others house sensory receptors. These are modified cells that create signals through ion channels that stimulate nerve endings, which then send the message to the brain. And there are some sensory receptors that also extend into the epidermis, but most of them are found in the papillary layer of the dermis. Also, one other thing, that papillary layer, let me back up a little bit. If we're looking at this, see if my pen works again. See this? So that's what we're talking about right there. That would be the top of the papillary layer. Guess what else that does? That helps create our fingerprints. Yes, it does. How about that? I give you that today for free too. So I think this is where we were. So on to the skin receptors that we find in this area. First, we have mechanoreceptors. These are mechanical stimuli, like stretching, stroking, or vibrating. In here, we have Merkel's discs. They help with sensitivity to light pressure. We have Meissner's corpuscles. They sense light pressure and low frequency vibrations. We have Pacinian corpuscles. These are deep pressure and high frequency vibrations. And Ruffini, I believe it's pronounced, corpuscles. And they sense stretching. The Pacinian corpuscles are encapsulated. And so the reason why they only get deep pressure sensation is because the pressure has got to actually push through that little cap around them to get down into the receptor. Then we have thermoreceptors, which sense heat and cold. Then we have chemoreceptors for things like when we have chemicals applied externally or released within the skin. One example that would be like histamine. The chemicals applied externally, any kind of lotion, or like, for example, old people like me like to use things like icy hot, stuff like that. That's what that does. It stimulates those chemoreceptors. And then fourth, we have nociceptors. They recognize both pain and itch. In one specific category, that is the proreceptors. That's what we call the ones that recognize that itching sensation. And then underneath the papillary layer, we have the reticular layer, the deepest skin layer. This one is highly vascularized, and it also contains our sweat and oiled glands. And it has some more deep pressure receptors. I need a drink. That's just water, by the way. Let me clarify that, okay? All right, on to the overall dermis structure. Collagen and elastic fibers are located throughout the dermis. Collagen gives our skin its toughness. Elastic fibers gives it its elasticity. And the blood vessels and our capillaries in there play a big role in body temperature regulation. Here's an image of our skin structure. You will see this again in when we get back from break in the lab, the Integumentary System lab that we do. There is a bunch of stuff going on in here, right? But we just went through all of this. Well, no, we didn't. We went through a big chunk of it so far. But we will continue to go through this and talk about the rest of the stuff that's in there. Let's see if there's anything. Just looking to see if there's anything I wanted to point out. Here, I was talking about the Pacinian corpuscles, the guys that sense the deep pressure. See, if you follow this up, see how that guy's encapsulated? So you got to push in through that to trigger it. So let's talk about some more of this stuff on here with the sweat glands and the hair follicles and the hair root and all this kind of stuff. So normal skin color determinants. One is melanin. We just talked about that. That contributes to the yellow, brown, or black pigmentation. There's also carotene, the orange yellowish pigment that we get from some vegetables. And there's also hemoglobin, the red coloring from our blood cells in the dermal capillaries. And then the oxygen extent will determine the extent of red coloring. So, for example, you have a lot of people who, like when they're working out or whatever, you might see that their cheeks or some other parts of their skin kind of turn red. It's where we got those capillaries closer to the skin, surface of the skin, that with the amount of extra oxygen we need pumping through there when working out, we'll have a lot more hemoglobin in there, and that's what will turn that coloring to red. So let's talk about some of the appendages. Cutaneous glands are all exocrine, meaning they secrete their products through ducts onto the epithelium, so through the skin and out, not into the bloodstream. So we have sebaceous glands and we have sweat glands that will do this. Then we have hair, the hair follicles, and our nails. Sebaceous glands, they're the ones that produce oil. They're a lubricant for our skin, and they prevent our hair from getting too brittle. And some of the acid qualities of it will help kill bacteria. Most of these have ducts that empty into the hair follicles, and then some will open directly onto the skin surface. So some of that oil will come through the hair follicles, some right onto the surface. And these glands are activated at puberty. And that's one of the reasons why, with the onset of puberty, some of us also struggle with acne because of the excess amount of oil that will trap bacteria in our pores and allow them to grow. So that's the association there. So here's a close-up of a sebaceous gland. And as you see, they're showing, as we look at this here, you're seeing how that would dump right into the hair follicle. And then here's one over here, a sweat gland that dumps directly onto the surface of the skin. And that's what we're on to next, the sweat glands. They produce sweat, of course. What else would they be? They're widely distributed in our skin. And we have two types, eccrine, which open via ducts to the pores on the skin surface, and apocrine, which have ducts that empty into the hair follicles. So here, if we're looking at this image again, eccrine, right, dumps directly out to the surface. And then the, back to here, the apocrine, they would dump into like this guy, even though that's a sebaceous gland. They would be ones like this guy right there that would dump into the hair follicle. Sweat and its function. Its composition is mostly water. You may notice that when you sweat, right? It has some salts, vitamin C, and some metabolic wastes. And the apocrine ones have fatty acids and proteins. Their function is to dissipate heat and excrete waste products, and the acidic nature of them inhibits bacterial growth. When we get odor, BO, right, from this, it's from the associated bacterial growth. We also have hair. By the way, we didn't mention this. The apocrine ones right here. Speaking of the odor, etc., and that, guess where we have lots of those? In our axillary region. Everybody remembers that's our armpits, right? Yeah, so there's where all the associated odor comes from those sweat glands. Then we also have hair. You may have noticed. Some of you, well, I still have some, right? Not, well, at least I think I do. Yeah, maybe someday you guys will have to deal with that too. But for now, enjoy your hair. Produced by hair follicles. Consists of keratinized epithelial cells. And the melanocytes provide the pigment for our hair color. Here's a cross section through a hair follicle, showing where we're looking at all those melanocytes down there, right? In the region of the growth zone, what they call that, in the hair bulb. And then it goes on up into the follicle, goes all the way up in here, and we get divided into a dermal and epidermal sheath. Okay. The anatomy of our hair. There is a central medulla, a cortex that surrounds the medulla, and the cuticle on the outside of the cortex. that there is what is most heavily keratinized. So it helps protect our hair, keep it shiny, all that kind of stuff. So with our hair, we have the hair follicle, which has, as we were just saying, the dermal and epidermal sheaths around the hair root. The erector pili muscles. These guys are smooth muscle. They pull the hair upright when cold or frightened. So you ever hear that, that expression, your hair stands up on the back of your neck or whatever? That's the erector pili muscle doing that. If you're cold, it'll do that to try to help by warming you up by generating a pocket of air that it traps around us, which hopefully stays a little warmer than the air, the colder air. It also does that when we're frightened. We also have sebaceous glands and sweat glands. Here's an illustration of that erector pili muscle. So this guy right there would expand or contract depending on the situation. There's a close-up of the hair. You see the outer part, the keratin wrapped around the cuticle, around the outer part. And we also have nails. Scale-like modifications of the epidermis. They are heavily keratinized, right? You just smack on your nails. You see how hard they are. The stratum basal extends beneath the nail bed, and that's where the growth comes from. The lack of pigment makes them colorless. Unless you paint them, right, ladies? Then you get lots of pretty colors on them. The nail structure, it has a free edge. The body is the visible attached portion. The root of the nail is embedded into the skin. And the cuticle is that proximal nail fold that projects onto the nail body. Right down at the base, you can see how that will flow over a little bit onto the nail. That's the cuticle. So if we look at an image of that cross-section through a finger. By the way, if you look at that down there, that little whitish spot, and that varies from person to person as to how big that is, that's the lanula. And then you see the cuticle right down here. You can see the cross-section where the cuticle is right next to that. The root of the nail down here, right? The body of the nail, the free edge, obviously that's the part that we have to trim if you don't want them getting too long. The stratum basal, that's where the growth comes from. If we follow that around up into here, that's where the growth comes from. Skin homeostatic imbalances, yeah. Just like other organs and tissues, etc., sometimes things can go wrong with our skin. For example, we can get infections. Athlete's foot, there's a pretty common one. Tinea pedis, it's called. It's caused by a fungal infection. You can get boils and carbuncles. Those are caused by bacterial infections. And you can get cold sores, and those are caused by viral infections. So we got just about everything wanting to attack us from the outside and on this one slide. We can also have allergic issues. Contact dermatitis, where the exposure causes an allergic reaction. I think far and away the most common one of that would be poison ivy, or maybe poison oak. Contact dermatitis, meaning you have to actually touch it. It's got to rub on your skin. And if you are sensitive to poison ivy, you know how problematic that can become. We can get impetigo, which is also caused by a bacterial infection. Psoriasis, an unknown cause. It's considered to be an autoimmune type of an issue. It can be triggered by trauma, infection, and stress. Or you can have another similar thing, but not. It's the appearance can be different, but it can be just as problematic as eczema. It's one of the things that I have. So there's a lot of allergic or autoimmune issues that can go on with our skin. Here's some beautiful pictures of those. Cold sores, the impetigo, and the psoriasis. Psoriasis is the hallmark, I guess, of the white scaly patches on top of all of the irritation. For things like that now, there are some biological medications that people can take that will greatly help in those situations. Then, of course, we can get burned. Obviously, the most common would be our sunburns. Cause tissue damage and cell death. But that can be from heat, electricity, UV from the sun, or chemicals. All of these things can cause burns to our skin. The associated dangers, we can end up with dehydration if it's too bad, electrolyte imbalances, and we can get circulatory shock in the case of excess burns. Not to mention the pain associated with that. And when we're talking about the extent of burns, the doctors and such, the medical personnel will use what's called the rule of nines, where they divide the body into 11 areas for a quick estimation. In each body, or each area of the body of those 11 areas represents about 9% of the total body surface. So you break it down like this. So we have 18% in each leg, 9% in our arms, the back and front are each 18%, 9% for the head, and then 1% on the neck. So they can, when you hear people, if you know of anybody who's received burns and they give an estimation of, X percentage of the surface of their body, they're going by this roadmap and basically looking at how much of each section was burned and using these values to give the final value for a percentage of the overall burn. And they also talk not just percentage, but severity of the burns. First, second, and third degree burns. With first degree, only the epidermis is damaged and the skin is red and swollen. With a second degree burn, the epidermis and the upper dermis now are damaged. The skin is red with blisters. And in third degree burns, it destroys the entire skin layer, and the burn turns it into a gray, white, or black color. So here's some examples of each, first, second, and third from top to bottom. Typical sunburns are first degree, although they can get as bad to be second degree too. But most often sunburns are first degree. But then if you get some of the other chemical burns or physical burns, things like that, you can get into second and third degree burns, which it always makes me sad to see that. When I worked at Shriners Hospital back in the late 90s, Shriners Hospital takes care of orthopedics and burn problems for kids. And the kids that would come through that had burn problems, to me, it was always just additionally troubling. I just felt so sorry for those kids. Burns are considered critical if they're over 25% of the body with second-degree burns, or 10% of the body with third-degree burns, or if there are third-degree burns on the face, hands, or feet. Any of these categories, they will consider burns to be critical. We can also, just like we'll talk about all year long with every other system, we also can have skin cancers. These are be classified like any other cancer in two ways: either benign, where it's encapsulated and doesn't spread, or malignant, meaning it is metastasized and moves to other part of the body. So the malignant cancers are the ones that are problematic. And skin cancer is the most common type of cancer. And I guess maybe that's not so surprising since our skin is exposed to everything. So that's the most common type. Of these skin cancers, there are basal cell carcinomas, which are the least malignant, yet the most common. And they arise from the stratum basal, which is why they're called basal cell carcinomas. There's an example of one right there. And then we can have squamous cell carcinomas. These can metastasize to the lymph nodes if they're not removed. Early removal, though, allows for a good chance of a cure, and they're thought to be sun-induced. And these guys will rise from the stratum spinosum. There's an example of a squamous cell carcinoma. Not attractive photos today in some of these, I know. Malignant melanoma. This is the most deadly of the skin cancers. Cancer of the melanocytes. They can metastasize rapidly to the lymph and the blood vessels. And with these guys, they do detection using the ABCD rule. There's an example of a malignant melanoma. Here's the ABCD rule. 1, you look for the asymmetry, where you have two sides of a pigmented mole that do not match. And then you look for border irregularity, where the borders of the mole are not smooth. And then you look for color, where we have different colors in the pigmented area. And you look for the diameter. The spot is larger than 6 millimeters in diameter. And an easy way to measure that, 6 millimeters, is the width of an eraser on a wooden pencil. That's right at 6 millimeters. So if it's bigger than an eraser on the end of your wooden pencil, it's bigger than 6 millimeters. And there's the end. There's the end of our slides. So I don't know. We'll see how far we get in the other classes as to where I'll ask Mr. Passy to stop today. But if you get through the whole thing and you get to this and are hearing me, then I'll just say I hope you have a nice break, and we'll see you all back in a couple weeks.